It is now my pleasure to introduce Dean Soyeon Shim. Dean Shim came to us not long ago. How long ago? How long have you been?
600 days.
600 days. 600 days. You have done a lot in 600 days. She came from the University of Arizona, brought with her many best practices and great ideas, and just a crazy innovative spirit. She is done so many things to initiate change, not only within her own school, but several initiatives that are engaging our entire campus. This is one of those, and please welcome Dean Soyeon Shim to introduce our speaker today.
So good afternoon. Let's try again. Good afternoon. That's better. But before I introduce our keynote speaker, Dave Franchino, I'd like to take a few moments to make some introductory remarks as to why we thought Dave Franchino would be the best speaker for this showcase this year, and also why you should care about design thinking. So, how many of you have read or heard of the book Creative Competence, released just a few months ago? Okay. And if you have heard of it but haven't read it, I recommend that you do. I think you might be really amazed to learn how much creative potential you have in you, and how you can unleash it once you gain that insight. Certainly, the author, Dave Kelly, knows a thing or two about creativity and where it comes from. He's a tenured professor at Stanford University, and also the founder of IDEO. And it's a Palo Alto, San Francisco-based international design and innovation consulting firm. I first heard about IDEO and design thinking a few years back when IDEO's innovative grocery shopping cart was featured on 60 Minutes. I was just fascinated about the process they used to solve actually wicked problem that consumers are facing at a grocery shopping stores, and a process that resulted in an innovative shopping cart design. And you can Google IDEO and 60 Minutes, it'll pop up, and there's shorter version and longer version, and it just really, I know that I'm confident that you will be also fascinated by the process. So at that time, I was still at the University of Arizona, but I thought the design thinking process would be a wonderful tool for our students to gain confidence in creative thinking and actually translate into action. But we didn't have the expertise or a platform to introduce concepts, so I just kind of put the whole thing on a back burner. And then Wisconsin called. So how many of you know that UW-Madison is a home for producing top designers? If you haven't learned about that, I invite you to come and visit our design galleries and design studios at Nancy Nicholas Hall, a really state-of-the-art facility, new facility. As a matter of fact, we have an annual fashion show coming up second week of May. It's fabulous. I mean, I think we're going to be at the New York Fashion Show here. But anyway, the tickets are on sale, by the way, internet, so you can just come and join us. But I just was amazed about the quality and talents of our students and our faculty. But anyway, in fact, I was very excited to come here, obviously for many, many great reasons, but partly because of these world-class design programs that the SOE has. And it's built upon a core principle of design thinking. Still, you might wonder why I am so eager to introduce this concept to the entire campus. For one thing, I was truly impressed by Design Summit, which Dave Franchino and our design faculty members and many of you from campus spearheaded. In its third year now, Design Summit 3, last month or so, brought together 250 people from all the disciplines on campus, along with business practitioners in the community. And I have to say, just about every college, including nursing, medical school, engineering, and law school, just you name it. And I was very impressed with this interdisciplinary team that they came together to learn about what design thinking is and how we can actually create something new here. So as one of the campus leaders, I felt really compelled to help this really faculty, staff, and community-driven grassroots effort and take it to the next level. So in an effort to learn more about how to apply design thinking then to our entire campus, so 12 of us, including Dean Jeff Russell is here, and Murray Carter, and several from engineering and College of Agriculture, we all went to visit Stanford's D School and spent a day and a half last February. By the way, I encourage you also to check Stanford D School website. It is very, very impressive, and you can see why Palo Alto and Stanford and San Francisco area, Silicon Valley, is our mecca for innovation. So people at Stanford D School say that it is a 60 years of overnight success with $40 million endowment gift that has made the school very successful. It has taken a long time, and it has taken a lot of money to achieve what they have done. But we don't have to compare with Stanford. We can do it differently using our uniqueness, something that's unique to us that they don't have. Number one, they don't have a design school like ours. So that's one advantage we have. But I think UW has so much more to offer for public and undergraduate education, and we're much bigger than Stanford. Building upon what we've learned, the deans and Provost DeLuca and Vice Chancellor Darrell Bozell, we spent actually an hour at Dean's Retreat last week thinking about, discussing about what it means for us, what would it take for us to launch here at the new initiative. We are at a very, very beginning stage of the conversations, but stay tuned for more information in the fall. So why am I still passionate about design thinking anyway? I believe that design thinking can be a competitive differentiator for UW students and an economic driver in the world economy. You see, today's global economy facilitates the standardization of innovations, but it also diminishes competitive advantages. Our competitive edge is going to depend on our ability and our students' ability to think creatively and find new solutions to problems and invent truly new products and new technologies. Now, we may not be able to match Stanford's success, at least not overnight of 60 years with a $40 million endowment gift anyway. But as I said, we have many, many talents here unique to our program, our school, and also community practitioners such as Dave Franchino. And we could assume a leading role among public schools. It's still early in the game. We can play a catch-up game, but we can be also innovator. I think we can apply the design thinking concept to teaching our students, undergrad students. We can apply to redesign our interdisciplinary graduate programs. We can also apply to Wisconsin IDEA to create social innovations and more effective community outreach programs. In fact, this summer, our design faculty members and working with many from other areas, public school, public health, and community, we are offering design thinking boot camp to build a healthy and wealthy community. It's going to be very much social innovation-driven class. So we should certainly be able to apply to improving the administration and university operation. We can also apply to several UW strategic priorities such as education innovation and D2P, and we have a new director, John Biondi, here staying with us, and Global Health Institute and sustainability. So what is design thinking anyway? And that's why Dave Franchino is here for us. He's going to enlighten us. Last year at this showcase, I mentioned that as a new dean, I was a newcomer in town. I was very impressed with many, many talented individuals and inspirational business leaders in the community. And Dave Franchino is one of them that I met early. Dave Franchino is currently president at Design Concepts. And prior to that, he has worked as a project manager at GM and was the lead designer on the team that designed the first line of Saturn automobiles. He has also worked as a product development engineer at IDEO. At UW, he has also taught as a lecturer in the College of Engineering, and he is presently the main sponsor of the UW Design Summit, which he helped to create. He received a Bachelor of Science degree in Mechanical Engineering from UW-Madison and a Master's in Mechanical Engineering from Stanford. In fact, he studied at Stanford D School, so when we were visiting there, the professors there were just so, they just think word of him, but I did make sure that he's a Badger at heart. And needless to say, we are very proud of him as well. Without further ado, please join me welcoming Dave Franchino to the podium.
All right. If I can salvage this, it'll be a miracle. So thanks for your patience. I'll try to speed up then. So where was I? I wanted to give a little bit of context of my career and basically how I came to be involved in the field of design and innovation. As Soyeon shared, I'm a Badger at heart. I was born in Milwaukee, went to UW-Madison for my undergraduate, and then I was fortunate enough to be the 50th employee hired by Saturn Corporation. And the reason I mention that is because from perspective of design and innovation, I entered GM Saturn as an engineer's engineer, really thinking that the secret to innovation, the secret to design success was all in the nuts and bolts, the mechanics, the gears, the sprockets. Saturn was 8,000 people when I left and had a very, very different perspective on what it took to be successful in innovation. Did my graduate work at Stanford and then returned to General Motors. So like all Stanford grads, I can now say that my first company went bankrupt. And was the manager of advanced vehicle engineering at Saturn for a while. I've done a startup, so I've got a little bit of experience at that. Together with three other Madison professionals, we invented a method of solidifying alcohol and sold that venture to BIC about 3 years ago. So it gave me a little bit of experience in the entrepreneurial world. But for the last 18 years now, I've had the opportunity to work for an incredible and marvelous company, one that's really shaped my life and my thoughts on innovation, and that's a firm by the name of Design Concepts, a really wonderful firm here in Madison that probably a lot of people haven't heard of. Our headquarters here in Madison, we've got about 60 employees, and we have staff in Minneapolis and Princeton, New Jersey, and this year we've opened an office in San Francisco. And Design Concepts is a product design innovation consultant. So I like to tell people that what we do at Design Concepts is work with people to help them envision the future. Where is there new opportunities, where their problems can be solved, and then realize those, bring those to life. And in that capacity at Design Concepts, we focus on product and service solutions across an incredibly broad range of marketplaces. And we've had the privilege in the 45 years that the company has been in business to work for a tremendously broad range of clients, a broad range of areas. And that's given me a perspective to see and learn in what I believe works in innovation, where innovation comes from. So before I start talking too much about design thinking, I wanted to stop and pause on that word that I've been talking a little bit about, innovation. We spend a lot of time talking about innovation. I think I probably heard it 4 or 5 times in the introductions to this speech. We don't spend a lot of time thinking about what innovation really is. I'm sort of reminded it was Chief Justice Potter Stewart said about pornography. I think his famous quote was, "I can't define pornography, but I know it when I see it." And I sometimes feel innovation is sort of the same way. So I'd ask each of you to stop and think for a minute. When I say innovation, what comes immediately to your mind? Did you think about Amazon? Did you think about that pair of Gucci shoes? What about Viagra and AK-47? Did those come to your mind when you thought about innovation? I hope not. But depending on your definition, how you choose to describe innovation, perhaps they should have. Is it fine to mention the Swiffer that helps me and my wife keep my floors shiny and clean in the same breath with the Hippo roller that helps individuals in drought-stricken areas bring life-saving water? Does that make sense? So when I say innovation, what do we mean? What are the types of things that we characterize innovation about? I'm going to pick on Daryl for a second. Daryl, what type of music do you listen to?
Mostly pop music.
Pop music. So why did I ask Darren what type of music Darren listens to? What would have happened if Darren would have said, I listen to Rachmaninoff, or I listen to the Beastie Boys, or I listen to the Dixie Chicks? Think about the mental taxonomy that's generated in your mind when those types of words get issued. The very best innovation in our lives can do those sorts of things for us. They can unite us as a community of people. We talk about ourselves in terms of I drive a Prius. I shop at Groupon. I'm part of a social cooperative. Those types of things can help define us as people. They can help unite us and connect us in meaningful ways that can really make a huge difference. So for a second, if you will, I'd like to consider a slightly different framework of innovation and one that helps me kind of lead into my talk on design thinking. So I'd like you, if you will, to kind of consider my business and what we work on and maybe how this applies to a lot of you in the room. We work in the field of design, which I would characterize as a broad brushes as being the identification of needs and providing solutions, and doing so in a way that generates benefit. Benefit for society, benefit for mankind, for users of products, services, and communications, benefits for the companies that are providing them together. So that equation, observing needs, providing solutions, and doing so for a benefit, is a really useful one. Because often when we think of innovation, we have a tendency to drive towards looking at innovative solutions. And what we can neglect to realize is a lot of times the real spark innovation doesn't necessarily come on the innovation side, or on the need side, or solution side of the equation. It comes instead on the need side of the equation. So what do I mean by that? Sometimes innovation is nothing more than finding a new need, a need that you didn't know existed before. An example of that we have in my industry is when we worked with a company named Diversey. Now, Diversey, some of you might know, it's a great Wisconsin corporation. They make industrial cleaning chemicals, the types of things that you would use to clean a building like this. So innovation in their world is often dealing about chemistry and chemical cleaning, saponification, those types of things. But one of their employees and managers was working with a bottling plant, the type of place that makes this sort of water bottle. I don't know if any of you have ever been in a bottling plant, but they're pretty amazing things. And the bottles are conveyed through the plant by these conveyors. They're called airveyors. They're actually kind of blown through by compressed air. And apparently the individual from Diversey was walking through the plant and noticed the plant was shut down, wasn't operating at that particular time. He inquired why. And the plant manager, whoever was with him, explained, you know, we blow the bottles through the plant of these conveyors, these airveyors, and over time dirt and dust and debris will build up on the conveyor, and if we're not careful, it could fall into the water bottles, could contaminate the water bottles, perhaps make somebody sick. So periodically we have to shut the plant down, to send people up on ladders, and they have to wipe down all of these tracks to make sure they're clean. Now, that's a really interesting that's happened there. So if you walk in as the manager of a cleaning company and you're thinking about cleaning products, suddenly you're presented with a new need, which doesn't look like a cleaning product or chemical. It looks like something completely different. So the solution to that is a little robot, the type of thing which, instead of being a cleaning chemical, is really designed to deploy the cleaning chemical. I've got a brief video of this, if I can figure out how to play this here. I'm going to see if this works. Yeah, there we go. Careful. There you see the bottles being conveyed through the plant. Here's the way it's currently done, and here's the little robot working through the plant. Kind of fun, huh? So sometimes innovation isn't focusing on the solution. It's uncovering a new need, a need that people weren't necessarily able to articulate. Another way to think about innovation on that need side of the equation is sometimes innovation is trying to solve a bigger problem than the one you were given to address in the first place. Another example of that we ran into in our career was another Wisconsin-based company, Bradley Corporation. Now, Bradley makes industrial laboratory systems, the type of thing you would wash your hands at in a building like this. And one of their big customers is Kmart. And I read an amazing statistic about Kmart. Did you know that Kmart is sued on the average of every 60 seconds? True story. Every 60 seconds, somebody files a lawsuit against Kmart. And a substantial portion of those are for slips and falls, often in the restroom. So if you think about it in the context of innovation, what does that mean? Maybe there's an opportunity not necessarily to provide an industrial lavatory system, but a way to prevent slips and falls. And how would we do that? Well, working left to right, we've got a soap dispenser and a faucet like you typically see, but then integrated into the sink is a high-speed hand dryer. So instead of dripping across the floor with your hands and leaving puddles of water that people can slip on, instead, you're blowing the water off your hands down into the sink you came from. So sometimes innovation is about solving a bigger problem than the one you felt you were given. In this situation, creating a tremendous competitive advantage for this company. We can't neglect innovation on the solution side of the equation. And sometimes innovation is really about solving those incredibly tough problems. Those ones that by all intents you think shouldn't really even be able to be solved. And a really amazing example of that It's a company by the name of Sadra Medical in the Silicon Valley. Now, Sadra Medical decided to take on a really tough problem known as aortic stenosis. We just had a delightful lunch here. Probably all of us ate a little bit too many fatty foods. Aortic stenosis is a buildup of calcium on the heart valve. And for those of you who are aware of anatomy, you'll understand this. For those of you like me who are newcomers to it, the heart valve sort of works like the flapper valve in the bottom of your toilet. It kind of opens up and closes depending on pressure. Use that as an analogy. And much like the valve in your toilet, calcium can build up on it, and over time it will begin to leak. I believe the anatomical word for that is regurgitation. So if you're reasonably young and reasonably healthy, you're a candidate for open heart valve replacement surgery, which is just about the most horrible thing I can imagine. They stop your heart, they open your chest, they open your heart, and they sew in an artificial valve. And I had a next-door neighbor who I believe kind of lost the genetic lottery. He's young and was reasonably healthy and had this disease and had to go through this procedure. And about 6 months later, he was doddering around the neighborhood. So it's a pretty serious event. If you are old and infirm or have other diseases, there is no option because you would not survive the surgery. So the only prognosis for advanced aortic stenosis is death. This company, Sadra Medical, decided, what if we can find a way to replace the heart valve, but do that without having to open up the chest, without having to open up the heart? Which in initial thoughts just sounds kind of impossible. But the approach they chose to take is pretty remarkable. And I've got a short video here. Once again, we'll test the AV and see if this works. They decided to incorporate an artificial valve into a stent. Now, many of you are familiar with stents, the type of things that are deployed inside arteries to help open a clogged artery. Let me see if this works. Are we running? We are not. Oh, sorry about that. So here we have a stent, very special type of stent that we're deploying into a beating heart. Instead of being a typical stent, this stent has an artificial valve incorporated into it. And what we're going to do here is we're going to deploy the stent over the top of the diseased heart valve, press that away to the outside of the aorta, and then when we're done, we're going to release the mechanism that deployed that and leave an artificial heart valve in place in a beating heart without ever stopping the chest. This came in through an incision in the leg, without ever having to stop the human heart. Pretty amazing stuff. So we were fortunate enough at my company to be able to assist the firm that developed this. We didn't develop the stent, the artificial valve itself. We developed the deployment mechanism that the doctor used to deploy this. So the objective was to use human factors, mechanical engineers, industrial designers to make it easy, intuitive, airproof, simple to use. In one of the weirder experiences of my life, those of you might mention, this is a product placement in Grey's Anatomy. It truly is. But there's enough excitement about this technology that it saw some initial play in Grey's Anatomy. And there you can see the surgeons, or actors as the case may be, deploying that valve. This company, about 75 people in the Silicon Valley, was sold to Boston Scientific for $390 million. And in conclusion, the CEO flew to my company and threw a party for my staff. And I was expecting him to say, "Thank you very much, you made me wealthy beyond my wildest dreams." Instead, he said, "Thank you very much, you're a really important part of saving a lot of people's lives." And sometimes that's what innovation is all about. So sometimes innovation is just about getting the whole experience right. Sometimes those of you who have Apple products know that it's not necessarily a specific thing you can point to other than the entire process of using that product is incredibly rewarding. Another really good example of that is Space Labs Healthcare. Space Labs is headquartered in Ishika, Washington, but their anesthesia workspace is here in Madison. And they decided to enter the anesthesia marketplace. Now, Space Labs is a healthcare monitoring company. Anesthesia was a new marketplace for them. And so they bought a company by the name of Bleeze, who is an English manufacturer of anesthesia workstations. In doing so, they had a sales and distribution network, but a fairly uninspired product. They really wanted to enter the anesthesia marketplace, but knew that this product wasn't going to create enough of a splash. So together with the folks at Space Labs, we traveled the world. We went to 11 different countries and watched anesthesia operations, tried to learn and immerse ourselves in the field of anesthesia, and find out what anesthesia was all about. And our designers and engineers, together with the folks at Space Labs, uncovered some interesting things that led to this device here. One thing we discovered was that anesthesiologists, unlike most of us, don't have a specific home they work from. They're more or less freelancers. They might travel from surgery to surgery or even hospital to hospital. And so a lot of us would look at this and say that's a medical device. An anesthesiologist would look at that and say that's my workstation, that's where I live, that's my desk. And taking into an understanding and accounting for that in the design, giving them storage and work surfaces and places to deal with, might sound like a really trivial item, but it really improves the quality of life of the individual who's using this particular device. Also, you might notice the picture on the left and the picture on the right show that this device can be collapsed down, can be narrowed in, which allows you to get through a door into the anesthesia workstation. Also allows the anesthesiologist to position the clinical part of the device, the left side, the healthcare delivering side, over the top of the patient, and yet reserve enough distance from the patient to leave the surgical staff room to work. I've heard anesthesia described as long periods of boredom punctuated by brief periods of terror. So there's certain times where the anesthesiologist is front and center, and other times where it wants to give lead to the surgical staff. There are a number of other initiatives in this, but I think when this product was introduced, the anesthesia community said, finally, somebody really took the time to understand how we work. You've really focused on making that experience right and perfect. And sometimes that's what innovation is, just that experience that makes us all feel great. So I want to ask everybody to kind of consider that innovation isn't just about solutions. It isn't just about technology. It isn't about high tech. It's about uncovering new needs, solving bigger problems, solving those really tough problems, and sometimes getting everything right. So a few of you in this audience might be getting a little bit squeamish. I realize I'm talking to an academic audience, and I realize all of this is talking about very applied stuff. And that's my life, that's my career. I'm not an academic. And so I recognize that the university has very broad missions, and not all of them are in the area of applied work. But aside from the fact that this type of thing is part of the mission of the university, I think I like to think of it this way. I'm an engineer, so everything has to go on orthogonal axes. Forgive me for that. But if you take a look, if we were to plot solutions on the horizontal axis and needs on the horizontal axis, solutions on the vertical axis, there's this area kind of hovering around the locus there that's where commerce and industry typically operate. You know, that's where we're working on the known inconveniences, incremental tweaks, the types of things I say that give us Honey Nut Cheerios. You know, Cheerios are great. Honey Nut Cheerios are actually awesome. But, but that's the area I think that commerce and industry typically revolves. I think as you push further out those two axes, you start to uncover areas where we begin to work on more unknown and more critical needs. It starts to talk about solutions that are more disruptive and revolutionary. And that's really where the next generation of our innovation is coming from. And I would even postulate that beyond that, there's a region of the new world where people are working on needs that are so critical, so intense, or discussing solutions that are so beyond our current level of knowledge, that that's really where the geniuses and visionaries live. And so from my perspective, that's the area, the place where UW can really do some amazing things in my estimation. And although the things that I'm talking about are design and they are applied, I think there's tremendous room for the UW to use the power of the intellect in this room and beyond to solve those sorts of problems. So I talked about what innovation is. Let me talk a little bit about where I think it comes from, and that'll lead into my talk about design thinking. So where does innovation come from? Mr. Jobs. You can't do a design talk without talking about Stephen Jobs. There is this perspective that sometimes innovation just comes from a visionary. Those individuals that are just so intrinsically wired into their marketplace, so brilliant, they're able to think and speak and envision on a level that's beyond the rest of us mere mortals. And I've had people postulate that that's really where innovation comes from, is for them, from these visionaries. I think there's a fundamental problem for that, and that is so often visionaries are often lunatics. And for this, I turn to my favorite source of all things true in the world, and that's The Onion. And I really hope I have those 3 stars positioned correctly there. So bear with me if I'm going to try this. This is F everything, we're doing 5 blades. Another visionary with the quotes, how did this happen? We were the effing vanguard of shaving this country, but you know what happened? Shut up, I'm telling you. They went to 4 blades. Well, moisture not, we're the chumps. F it, we're going to 5 blades. I actually think I worked for this guy at one point in time. Here's that report from engineering. They don't tell me what to invent. I tell them. So sometimes I think one of the problems with visionaries is all the things that make them self-directed and confident. You're reading it, aren't you? Yeah. This is priceless. Of course, this is clearly fiction. The idea of doing a 5-blade razor could never come to bear. That's ridiculous until Gillette introduced the 6-blade razor. Probably done as a very expensive joke. So if the visionary isn't always the source, what's the antithesis of that? Well, there's another body of thought that says to learn what people want, we just need to ask them. There's the voice of the customer. If we just have a process where we can listen to the voice of the customer, that's where true innovation will come from. And I think there's some fundamental problems associated from that as well. A while ago to chat with a really brilliant business leader, a vice president of a medical device company named Decaria, and he was relaying to me a really sheepish story. He said a long time ago, he said, probably, I don't know, mid-90s or so, he was invited to participate in a marketing focus group. Anybody ever participate in one of those? It was organized by a major cellular phone provider, one of those ones where they bring you into a room and they ask you questions with people behind the glass very carefully taking notes. And they were asking about his preferences on cell phone. He was sharing at the time, and this would have been, 10, 15 years ago, he was an amateur photographer. He said, I distinctly remember telling these people, I don't want all this other stuff on my phone. I want my phone to be my phone. If I want to take pictures, I'll go get my camera. Which in retrospect sounds a little bit embarrassing, doesn't it? So one of the problems with the voice of the customer is sometimes people aren't always able to envision where the future is or what it lies like. So that presents us with a little bit of a dilemma. If the visionary in the best end can give us the Apple products, but in the worst end can give us the Pets.com pop sock, or sock puppet, and if the voice of the customer can give us in the best the Nintendo Wii, and the worst can give us the Pontiac Aztec, then what's the solution hold for a methodology for innovation? I'm talking to an academic conference here. And so one of the first things that comes to mind is our old friend, the scientific method. A lot of us remember the scientific method. Hopefully, probably use the scientific method. I have to usually explain this. Most of you could explain this to me. But we remember that. You can ask a question, what is the future of anesthesia? We construct a hypothesis. We test the hypothesis by doing an experiment. We analyze that data. We draw conclusions. Everybody remembers that, right? So that seems like a useful construct for approaching innovation. One of the problems is that a while ago, people started to talk about these types of problems that defied scientific description. The phrase was coined, I think, in the 1970s, wicked problems. It was based on research by, I'm reading this now, Horst Riddell and Melvin Weber. The 73 treaties, they described wicked problems as those ones where there is no right answer. In fact, the solution depends on how you choose to define and frame the problem. To make matters worse, sometimes how you define the problem depends on what solution you intend to approach. They also said stakeholders have radically different views, constraints and resources change over time. The problem is never definitively solved. Unfortunately, that describes a lot of what we end up working on in a lot of our days, right, doesn't it? So there's a field of thought that this scientific method, although it has a lot of validity, isn't necessarily the best approach for solving these sorts of problems. And around that time, a tremendous amount of interest started to rise in looking at how designers solve problems, creative design thinkers. Part of the rationale behind that is designers are used to attacking problems where they don't necessarily have a background in them. And they're used to working on problems that have very ambiguous constraints, and solution is often subjective. Success is subjective as well. And so a school of thought began to raise that talked about the power of this design thinking that Soyan has mentioned earlier. So what is design thinking? You're going to recognize all of the components of it if you haven't heard the phrase. A lot of you recognize that there's this perspective that innovation starts with asking a question and traverses a fairly linear path to some sort of a solution. But in reality, the process probably looks a little bit more like this. Design thinking is a process which is designed to recognize, capitalize, and account for this level of ambiguity. So like design thinking, or like the scientific method, we start with a question, but we have three specific phases: discovery, redefinition, and then a solution of the problem. So starting with a question, we start with a question, but in design thinking, we generally assume that what we've probably done is ask the wrong question. That's one of the key ways of starting design thinking. And because of that, as we move into discovery and how we're analyzing and informing ourselves on how to solve this problem, we broaden the areas of discovery and research out beyond the traditional areas. If I was asked to design a bridge as an engineer, I might start to research bridges. What are materials for bridges? What are types of things for bridges? In a design thinking approach, we step back from that specific solution and look contextually much broader at that specific area. And that starts from our perspective at three broad areas of inquiry around the basic area. First is something that's often neglected, which is to begin by researching your organization, the UW. And starting by understanding that if we're going to solve this problem in the context of the UW, we have to start by clearly understanding the organism that's going to be adopting and maintaining this change. What is our vision? What are our organizational strengths and weaknesses? What are our core competencies? What is our appetite for risk? And taking the time to understand that is a critical part of informing and discovering a background for design thinking. Moving on to understand the world at large. What is the ecosystem in which our solution is going to have to live? Are there social trends and contextual trends that are changing? What's happening in the regulatory environment? What's happening in government? Fortunately, there's been nothing happening in government that's affected the university, so it's not an area you have to look at right now, right? But I've heard it said that a lot of the great innovation comes from understanding and capitalizing on social trends. Look at all the green and sustainable products we use right now that would have made no sense 15 or 20 years ago, but now make a ton of sense. And then finally, a specific spot of design thinking, discovery research is understanding the people and places in which the innovation is going to have to operate. And that goes beyond simply talking and listening to people, but into developing empathy. So if you think about empathy, that's really the ability to see the world as other people see the world and share their perspectives. When we flew our design team around the world to uncover that anesthesiology opportunity, it wasn't just to learn about anesthesia, it was to learn how to think like an anesthesiologist, to try to understand their pain points, their constraints, so you can reflect those in your day-to-day actions. So if we look at this graphically, we started with a question on the left-hand end, but during that discovery process, through empathy, through discovering context, through studying people and places, the sphere of my investigation has actually gotten broader, not gotten narrower. And that leads to the second critical step or characteristic of design thinking, which is having the courage to reframe the problem. To understand that the problem I went in with is probably not the problem I come out with. I think I'm going to read this. Albert Einstein once said, if I had an hour to solve a problem and my life depended on it, I would spend the first 55 minutes determining the proper question to ask. And once I knew the proper question, I could solve the problem in less than 5 minutes. Another way to think of that is, what's 5 plus 5? The answer to that is 10. What are two numbers that add up to 10? There's an infinite number of solutions to that. So how you look at the question is really significant. I talked earlier about it being an engineer and being asked to build a bridge. And as an engineer, I would be down the track and running on that. Should it be a suspension bridge? Should it be a pylon bridge? Should it be a steel bridge? If I ask somebody why you need a bridge, oh, I need a bridge to cross that river, that's a very different problem now, isn't it? You know, how are the ways to cross the river? Maybe it's a subway. Maybe it's a ferry. Maybe it's hot air balloons. I don't know. Why do you need to cross the river? Well, there's goods and commerce that need to come and flow across that bridge. So maybe the problem isn't a bridge. Maybe what we need to do is buy local flavor. Design thinking is the only process where you can start out designing a bridge, end up opening an organic restaurant, and consider it a success. So using that redefinition now we can begin to neck down. We used to think, now we know, now we believe, down to a narrower understanding of the problem, and then move into the solution phase of the exercise. And one of the key characteristics of design thinking is this continual cycle of ideation, prototyping, and testing. By ideation, we start with the power of the team, the power of brainstorming. A lot of you are familiar with that. But using and harnessing the collective group of individuals to create not just a single opportunity, but a wealth of opportunities. And that's another area where design thinking often departs from traditional methodologies. There's a quick sketch that somebody from our team once did we were working with General Motors on the Volt battery pack. They were trying to solve a leak problem on the Volt battery pack, and they did a quick sketch of what that solution might look like early in the process. They didn't stop there. They did more sketches. Here's more ways we think we can solve that problem. They didn't stop there. Here's more ways we can solve that problem. So one of the tenets of design thinking is not to follow this iterative approach where we pick a specific solution, test it, determine if it fails, but instead try to cast the net as wide as we possibly can, and then use the power of the team to try to identify promising alternatives. Next fundamental tenet of design thinking is the concept of rapid prototyping, working very, very quickly with low-fidelity objects to mock up your solutions and test them as quick as you can. Here's one of our engineers testing a paper prototype of a user interface. We haven't written any code. We haven't programmed any computers. We've scrawled on scraps of paper what the user interface might look like. Remember that anesthesiology workstation I told you a while ago? Here's an image of a couple of people working on a cardboard and plywood prototype of that anesthesia workstation, trying to understand how it might pertain. So using these low-fidelity tools to very rapidly explore alternatives. And then finally, another key tenet of design thinking is testing these concepts with users, taking the time to actually immerse these concepts in the lives of the users and get their perspective with it. So that rapid cycle of ideating, prototyping, testing, refining is the final tenet of design thinking. And then using that methodology to narrow down to a final design solution. So although many of the steps are very similar to scientific thinking or to more analytical thinking, there are some characteristic differences. Where scientific method, we're seeking an answer to the question. In design thinking, we're assuming we've got the wrong question. Scientific method seeks truth. There is no truth in design thinking. Scientific method is objectivity, rationality, analysis, linear, and methodical. Design thinking, empathy, creativity, solve by synthesis, highly adaptive. So this method is, and probably no surprises in what I'm talking to, going through the poster, which I had an opportunity to do, all of these are tools and methods which many of you are employing today, whether you knew the words or not. So this is really caught on. Design thinking is really catching on from an academic perspective. So Yen talked about the D School, or the Haslo-Platter Institute of Design. MIT has a great design thinking program. Harvard, the Siegel Institute down at Northwestern, to name just a few, are programs which are really focusing efforts on this. Beyond that, I doubt if this presents too much of a challenge to our folks at the B School, but the Wall Street Journal is saying, forget B School is hot. So that's it. Is design thinking now the reigning problem-solving methodology? Is this the solution? We can toss away the rest of it. I think everybody's familiar with the sifting and winnowing plaque, hopefully here. Yeah, I still remember as a young kid my father taking me to reading those words in awe. If design thinking had been around, I think instead of saying, by which alone the truth can be found, design thinking might say something like, by which alone a contextual, reasonable solution to a slightly different problem than one we originally thought we were trying to solve can be iteratively identified and implemented. So let's be real. There are huge limitations to the extent and scope of design thinking that need to be understood by this university. Jonas Salk did not discover the cure from polio through a deep process of empathy. And I have no idea who invented inkjet printing, but I'm fairly confident that it didn't come from observing latent and blatant needs. You know, there are specific things that have to be done using scientific methodologies. And You mark my words, we will see a backlash against the phrase design thinking. It's probably already begun. Given frustrations around the ambiguity of the process and fuzzy empathy and reframing and rapid prototyping, you'll hear a hue and a cry that it's time for the adults to re-enter the room and take control of the process. All those sorts of things are true. But fundamentally, I think regardless of your choice of words, the elements of design thinking are a very powerful problem-solving methodology for certain types that have to be understood. And the tension and the conflict between these different methodologies in schools, in my estimation, is where UW can really firmly make their mark. Because I think there's tremendous room for educational pedagogy that breaks down the barriers between these different problem-solving methodologies, whatever you want to call it, design thinking versus scientific method, right brain versus left brain, the analytics versus the creatives, you name it. This frustration, this conversation has been around forever and will continue to be around forever. UW can lead the way in trying to identify how to break down those barriers and make it so it's not those two different methodologies, but a blended methodology that makes a lot of sense. Now, that's a really, really tough problem in academia. I would argue that it's harder for you than it is at companies such as mine, because there is no inherently more siloed organization on the face of the planet than higher academics. And I noticed some laughs, but please don't laugh at that. There are good reasons for that that make sense, that I understand. It's one of the things that makes this a wicked problem. You take a look at the way we talked about my taxonomy of innovation or design before. I talked about needs and benefits and solutions. Well, the reality is that we tend to educate people in specific silos and then not notch them into a specific area. Depending on your academic background, you might be in psychology, sales, marketing, strategic planning. You're needs people. Or if you're accounting, financing, purchasing, you're the benefit people. Computer science, science, engineering, law, those are the solutions people. Very compartmentalized, very, very siloed. Notice I haven't even mentioned on here the arts, sculpture, music, dance. They don't even get a place on this particular map, on this particular table. And that's a fundamental flaw, a fundamental challenge, I think. Roger Martin, the brilliant dean of the Rotman School, put it this way. The fundamental problem is that problems rarely lie within the boundaries of individual functional areas, but rather sprawl messily across the function. We have multidisciplinary problems in general. And so I really believe that the solution for certain classes of innovators is move beyond teams of or multidisciplinary teams to teams comprised of multidisciplinary individuals. And that, I think, is a worthy challenge of the people inside this room. Because if you look at many of the innovators who we consider to have tremendously moved the world forward, they fit this type of mold. Leonardo da Vinci, Bill Gates, Steve Jobs, Ben Franklin. I noticed when I would meet some of the most creative and innovative people at a cocktail party and I would say, so what's your background? Inevitably, really creative people would have to double clutch on that. They have to say, well, geez, I've got a degree in business, but I also have a degree in engineering, and I play in a band on the weekends. And those types of backgrounds tend to be consistent with those people who are really effective from an innovation perspective. And I think we all recognize and see that. So I really believe, to a great extent, this concept of a Renaissance innovator is one that the UW, from an academic and a pedagogical and a scholarship perspective, can understand and address. How do we create people that can be part entrepreneur, part designer, part cultural anthropologist, prototyper, brainstormer, intellectual property people? How do we create individuals that have this incredibly broad range of background? And I will leave you with this last parting challenge. If a young Steve Jobs were to enroll here at UW-Madison, and Steve Jobs dropped out of college because he didn't find what he needed there, probably good. But if he were to enroll here at Madison, what would his educational experience be? What classes would he take? Who would claim him for their own? Would it be art? Would it be engineering, computer science, in business? The people in this room can create an environment where the next Jonas Salk can be working on the cure for polio, and the next Stephen Jobs can be working, and they can collaborate and integrate together. I think that's a worthwhile challenge. I can think of no better place on the planet than that to occur at this wonderful university. Thank you for your time, and on Wisconsin.